my name is Alex Hoffman. Thank you so much for joining us today. I'm with the Equipment Dealers Association. Really appreciate you sharing a bit of your Wednesday with us today. It's my pleasure to introduce to you Carl Aakre. He's going to be our presenter today. Carl is currently the curriculum coordinator for CASE, the program that creates and delivers agricultural science education to teachers in the U.S. EDA's foundation has been supporting CASE for the last couple of years through partial teacher scholarships. The teachers who attend these CASE institutes bring ag education back to their classrooms, so the impact reaches thousands of students each year. And I'm so excited to share details about that program with you today. Before we begin, just a couple of housekeeping items. First, we encourage you to ask questions. There's a Q&A box on your screen. Just type in your question. We'll answer it aloud for the group. If we get some during the webinar, Carl will just pick them up and answer them as is, and then we'll just make a little extra time at the end for any additional questions. Secondly, there's a recording of today's webinar that will be sent to you after the presentation. Expect that tomorrow. We'll also send along with that a copy of the slides so you can review those, share them with others in your business. And that's all for me. Thanks again for joining us, and I'll hand it over to Carl.
Thank you very much, Alex. What I'd like to do first is just give a little bit of background about what CASE is and how we're managed, where we started. CASE has been a project since 2007 when it was started by the National Council for Agriculture Education. We are managed by the National Association of Agricultural Educators, which is a professional organization for all ag educators to be members of, with a specific focus of professional development. When it comes to CASE, we have two core areas. One is our development of new curriculum, which are two turnkey systems of curriculum that are year-long agri-science courses. The courses that are sponsored by EDA are the Agricultural Power and Technology course and the Mechanical Systems and Agriculture course, which are the two courses in our agriculture engineering pathway. All of our courses are aligned to national standards, national AFNR, Ag Food Natural Resource Standards, along with next generation science standards, Common Core technical writing and reading standards, along with Common Core mathematical standards as well. All of our courses have end of course exams where students can receive a certification saying that they are competent in all concepts and performance objectives within the courses, and we also provide online accessibility. EDA has sponsored the professional development, which some of you may have heard of as being CASE institutes. Our institutes are between 8 and 10 days in length of rigorous training for the teachers, so they go through all the different activities, projects, and problems that the students do in the class, so they are well prepared to teach all the material to the students, so they're ready and prepared. We also provide curricular updates at those professional developments, and we've also found too that we've really gotten a really cohort of educators, especially the ones in the ag engineering pathway that have completed the two courses, Ag Power Tech and Mechanical Systems and Ag. They really have bonded together to share their ideas and things on how they can expand and improve the curriculum. As I've said before, we have multiple pathways. The pathway I'm focusing on today is the Agricultural Engineering pathway, which is the Ag Power and Technology course, and the Mechanical Systems and Agriculture course. These courses are the newest courses within our curriculum. We've had our plant science courses and our animal science and natural resource courses around for approximately 10 years, where our Ag Power Technology course has only been around since 2015, and Mechanical Systems and Agriculture has only been around since 2018. So these are the newest courses that we've added to our curricular menu. When we design all of our curriculum, we try to put everything that's inquiry-based. Inquiry-based so that we ask questions, get students thinking in an agricultural context, and spiral and scaffold our curriculum so we build upon things. And I'll try to show you that here in a moment. And again, everything is really based upon STEM. We've really focused on integration of science, technology, engineering, and mathematics through all of our curriculum in an agricultural context. These CASE institutes, like I said before, are very extensive, rigorous, skills-based, hands-on, and they're led by teachers. And that's one that the title of the presentation was Teachers Teaching the Teachers. What we do within our program is we don't have any professionals outside of industry teaching. We have actually teachers that are in the classroom that have experiences using the curriculum, that have worked with industry in the past. When we developed the curriculum, to teach the other teachers. Those teachers that go back in the classroom and use it for a few years, then come back and become new lead teachers to train additional teachers. So we have a good sustainability model for professional development. Now I want to go a little bit into the development of our curriculum. When we started looking at the agricultural mechanics area, agricultural mechanics careers, we had a curriculum development committee. That was a committee of both ag industry professionals, individuals from post-secondary institutions, and teachers in the classroom that are teaching agricultural mechanics. And we asked them the question, how can we prepare students for a variety of ag mechanics careers? And many that do not exist today. And what core ideas and skills does a student need to learn and understand at a secondary level before moving on to post-secondary training? The overall thought that we came up with was we want to prepare students to be independent thinkers and problem solvers in the ag mechanics career field. And we want to engage students in the core science principles, technical skills, engineering skills, and math applications. And we want to do all those in an agricultural mechanics context. The problem that we found when it comes to agricultural mechanics is when we go across the country, it's defined many, many different ways. Some teachers focus on structures and surveying and soil conservation, while other ones will focus on woods. Others are primary welding programs. Some will do some metal fabrication. Some will focus only on small engines. Some add a little bit of GPS and GIS here and there. We found it all over the board. So then our thought was, how do we put this all together? What core concepts and ideas, and how can we put it in a way that meets all the teachers' needs? And when it came to teachers' needs, when we're asking teachers for what they needed in regards to all those areas, the top thing that we heard from them is that there's a limited experience of training that they've had in ag mechanics. A lot of teachers that are coming out from college, the only thing that they're really teaching in the classroom was what they learned in grades 9 through 12. And when they were in college, they maybe had 1 or 2, possibly 3 courses in ag mech that were very sparse. And they didn't have a lot of in-depth knowledge to become competent to teach students in the shop, which went to diverse shop settings. We had teachers that had classrooms that had a very extensive shop with all the equipment you could imagine. We had other teachers that come from shops that didn't have a lot. So how do we design a curriculum that can meet the needs of both those type of teachers with limited tools and supplies? And we've also heard about the integration of new technologies. What new technologies are out there that we should be implementing in the classroom for students to prepare them for industry and keep it active and hands-on for the students. Throughout all the curriculum, we've identified some major standard practices and processes that we use throughout. One is on project planning. So when their students are designing any of their projects, whether they're on the electrical side or the mechanical side or structural or machines, we look at the engineering design process, and that is used consistently throughout both of the courses. Another piece in industry that we understand is very important is safety. So we ended up with standard templates and procedure for students to use for evaluating tools to be sure they're safe, and proper procedures for tool operation. And then other core area is problem solving. How do we teach the troubleshooting process so students can efficiently, effectively solve problems while they're in the shop, in the classroom, and then when they move out into industry as well. The agricultural power and technology course, which is the first of the 2 courses, which can be broken up into technical skills and engineering skills. The technical skills, like I said, like before, are project planning, safety, those standard tool procedures, focusing on measurement, material selection, material sciences. How do we fabricate those materials? And then as we put those into a machine, how do we maintain and calibrate those machines? On the engineering side, that's where they introduce the engineering design process. Look at how machines are designed, the different types of energy sources, mechanical energy, electrical energy, and chemical energy, and the physical and chemical properties of those materials, energy, machines. So they can come up with a core understand how all machines, equipment work, which we find helps them do some of the troubleshooting and problem solving as they move into the future. The safety portions throughout both courses review OSHA laws and regulations, PPE requirements. One major focus we looked at too is how we prevent accidents from happening through identifying the root causes of those accidents, what a near miss is, and a reporting of near misses in the shop, which is a portion that we've added as well. first aid and proper first aid in the shop, and 2 operation procedures, which we identified with 3 different areas: a point of operation, power transmission, operating controls. And if students can look at a tool, they can actually identify all 3 of these parts of a tool in anything, whether it's a real complex tool, which you look at as a small engine, or a power saw, or down to a simple tool such as a handsaw. They all have a point of operation, power, transmission, and operating controls. When we heard from industry when it came to measurement, we understood that we had to integrate all areas of measurement, whether it's decimal or fractions, which we heard that was a concern. Throughout both courses, we jump back and forth. Sometimes they're using fractions, sometimes they're using decimals, sometimes they have to use conversions, multiple equations. They have to understand how to use what a tolerance is and how those are important, using proportions, especially when it came to calibrations, for example, with sprayers. So we integrate all those things throughout the entire course when it came to mathematics. When they're introduced to the sciences, when we focus on materials, besides we look at, like I said, we talk about woods, metals, and plastics, and we look at the chemistry of those, so they understand why we use certain types of metals with equipment and why we use different types of plastics. So in the classroom, they learn about how different metals react together, as you can see in this simple lab activity, with aluminum wire wrapped around a steel nail, and then you can also see another steel wire wrapped around a steel nail. You can see how the different ones react and where corrosion actually occurs, so you understand why different types of metals are used. And then when it comes to plastics and polymers, they actually make some different plastics and polymers in the classroom to understand the chemistry of those and why we use different types of plastics for equipment than others. On the physics side of energy, we focus a lot on electrical energy and electrical controls. You can see here in this snapshot what the teachers are actually doing is they're using a variable they're using a variable resistor to control the amount of electricity that's going into a water pump to pump water into that graduated cylinder. And they can read those readings of the current, the potential voltage, the power, and the resistance, which is coming from the variable resistor on the meter screen. By doing that, they can actually develop a calibration chart for that pump, so they can calibrate based upon the amount of resistance they put in those electrical controls, what is going to be the rate of the water pump. That is a very simple way to teach for students or for teachers to show students how things actually work for a sprayer and how to do some calibrations. And we can do that in the classroom in a very contained area instead of a very large area where the teacher may not have a large area to bring in a sprayer into a shop to do that. Well, now there's something that they can do that integrates the sciences, shows them energy, electrical controls, and how that relates to outputs in agricultural equipment. Another area of focus in the first course is use of a windmill. They use the engineering design process at the beginning to construct a basic windmill, and then they measure the efficiency of it. They learn about horsepower, they learn about watts, and again, this is very simple. It's amazing how much power students are able to get out of a simple windmill made out of literally scrap materials. But as the course builds and builds throughout, we start to add different pieces. So we talk about fluid power, which in that fluid power is wind. What's that fluid power? We look at gear ratios and torque, lubrication, the difference between speed and torque, how we generate electrical energy, and the calibrations. And it culminates into all of this. So we now have a fluid power and how we can make that most efficient using Bernoulli's principle for the wind. And then we have those gear ratios set up in there. And if we get the gear ratio set correctly, we can generate enough electricity to go back again then with spiral scaffold back to that water pump that simulates an irrigation system. So they understand the system's thinking about how we can transfer energy all the way to machine and understand the science, technology, engineering, and math that goes all behind that. Another project that they do at the end of the course that they're given, after they've learned about all the different procedures, is they're given some scrap materials like they did with the windmill. And I'm saying, okay, how would you make a planter? What would you have to do for the seeding rate? How would you have to adjust the planter for the size of the seed? How would you get the seeding rate correctly? How would you fabricate that together? How would you test that? So that's an example of a small problem at the end of the course that they're able to do at the end of the first course. And then we build upon that in the second course to make it a little bit more complex, which is the second course here I'm going to talk about when it comes to our pathway, which is mechanical systems and ag. This course integrates, again, those technical skills of safety, but more into technical drawings and CAD, reading a schematic and print, analysis, troubleshooting again, but now looking at failure analysis, more into equipment calibration, equipment applications. And on the engineering side, how do we prototype things? How do we prototype and design new pieces of equipment? How do we think and problem solve using systems thinking? Because of all electrical controls, why do we have to understand computer programming? And what are the robotics that are related to that and automation? And how is that coming into agriculture? And why do we need to understand that? Throughout this part of the course, or this course, they start with some computer-aided design and do some drafting. They learn how to draw and read prints. But more importantly, besides just doing that, they're able to make all those parts through prototyping using a 3D printer. We found that's really valuable for a lot of teachers because a lot of school districts now have 3D printing technologies. More of them have that type of technology than they may have a metal lathe or a mill to mill out and machine parts. So students may not learn how to mill or machine parts within this course, but at least they're able to design things and are able to print them and use them as prototypes to get their hands on them so they can really understand the difference between what a print actually shows and what the part actually is. So they can start to understand those tolerances that are important to make sure all the parts assemble and fit together correctly. We also start to go through programmable logic controls and PLCs and those controllers and inputs and outputs and how to set up a pseudologic model so they can learn how we can automate things and automate types of machines. So the one on the left there is an example of a simple GPS GPS line follower. So like example of a light bar, the light's in the center, then they're going in a straight line. But if the light turns on the right or the left, that means they have to veer back the other way. So you learn how GPS and GIS works, but also how that works electronically and the controls that go behind it. And then on the right, you see a more complex PLC, which is a VEX controller, which we use in a lot of our robotics controls in the classroom. As I said before, we talk about systems thinking. When we talk about the machines, or excuse me, our systems area, our three systems we use in the course, are structural systems, engine systems, and machines. We do the engine systems portion for this course. We focus on a small gas engine. When we look at that, we look at all the different systems and how they work together for them to understand the full analysis. Besides just tearing the engine apart, identifying those parts, putting it together, how do those parts work together? How do they integrate? In the past course that they did in Ag Power Technology, they learned about different types of energy and how all that energy works and how it's transferred from one place to another to actually put out work and put out power. Been able to do that now we put that into a small engine, looking at all those different systems. So, okay, now if there's something goes wrong in one area, how does, for example, a problem in the machine lubrication and cooling area, how is that going to affect other areas of the machine? How are they related to each other? And the machine systems area, after learning about engines, well, they got engines going to power some type of machine. So then we start talking about geared systems and transmission. What we've learned, or what I've seen in the past, is I've seen a lot of teachers, for example, when I was a teacher in the classroom, we would go out in the shop, I would have an old SE case tractor or something else there, we'd pull the back end off, we'd look at all the different types of gears and say, okay, see all these gears, when we shift those gears, they move and they transmit different power or speed or have different torque. But the students are able really to do anything with that. They get to look at it, they see it, the teacher gets to talk about it. What we really want to do with this course is we want them to experience those types of things. So in this course, we use some robotic parts for them to design and construct their own transmission system. So this is a 3-speed transmission system that they designed in the classroom. So they design this transmission system, they put it together, and then they measure and compare the difference between torque and speed, run it through a multimeter, so now they can see energy draw as well as they're running the electric motor to power these. In addition, there's a clutch on there with a slip clutch, so they learn a little bit more clutches and how clutches work along with the transmission systems. It's a smaller piece, but it's very hands-on for all the students to get involved. Once they learn about machines and transmissions, Then we would take it up a step a notch. We talk about tractors and gets them interested in that way about, okay, now we have that transmission system. How does that work in a tractor? What are the things we have to be concerned about when designing a tractor? And again, we wanted to tie in this to all students so they can all be involved with this with projects and processes instead of just we can pull in a tractor, talk about weighting systems, stability, we can look at different hitches, but how can we actually get them involved with it? During this course, they assemble a robotic machine, which actually we call it a tractor, but it is just a robotic platform. But the hitch is too high, the weight is not weighted properly, and when that happens, of course, the tractor flips over and it's not able to pull a lot of weight. So we were able to teach stability, hitching, gear ratios, traction, weight, torque, as you can see everything I here and talk about on the screen. And they have to redesign that tractor. And that's where the inquiry comes in. Students can do whatever they choose within certain limitations that the teacher sets with materials they have to redesign that tractor to get the most possible pulling power out of it, which then becomes a competition in the classroom about who can pull the most weight with the tractor. And as you can see in this picture right here, there is a this is from a Case Institute where the teachers actually have their own little pull off and tractor pull where they get very competitive with it. And as you can see on there too, there's also a multimeter. So besides saying, oh, I pulled the most weight, well, how efficient were you with pulling that weight and how much energy did you actually use while pulling the weight? When it comes to inquiry and application, we've actually seen a lot of new things come out of this project with students. I had a teacher that I talked to from Kansas who had, the students had taken the Ag Power Tech course and they'd taken this course as well. And their goal was to get this simple it's a 7.2 volt motor to pull weight. And they said, well, we want to get to pull 100 pounds. They got it up to 65 pounds. And after they got it up to 65 pounds, they had a problem. The thin metal shaft that they're using, which is a 1/4 inch, or excuse me, 1/8 inch metal shaft, was starting to twisting off. They had plenty of torque and the gears would work, but they were twisting it. So then they learned from their material section in the Ag Power and Tech course that, hey, well, this metal is too soft. If we harden it, it won't twist. So they went back and they hardened the metal because they understand the properties of steel and metals in their Ag Power Tech course, used those properties to problem solve so that they could get the tractor to pull 100 pounds. After they have designed that tractor platform, then we go into GPS, GIS, and automation and look at sensors and the program controls within those sensors. All machines now have sensors all over them. And we want students to understand that and how they actually work. So we give them, after going through some programming, understand basic C programming and sensor controls and PLCs, they add that to their tractor. So now the tractor has to solve a problem. It has to go through an orchard. As you can see in this picture here, here's the shed right there where the tractor had to start in the first place. Has to navigate itself through the orchard without hitting any of the trees so it can spray the entire orchard and then park itself back in the shed. Using sensors in programming. So if a tree were to fall in the way, it would automatically stop. So you have to think about safety as well. And then energy usage too. So we do electrical systems. They can test all their circuits because they've had circuitry problems with them as well too. So here's an example there. The next portion that we've added to that when it comes to machines and power transfer, besides looking at gears and power transmissions and other ways, is fluid power. We do not do hydraulic systems in this course just because of the mess and concerns we had for safety with students from teachers. So we focus on pneumatic systems. They learn how to read a schematic. They learn about all fluid power principles and fluid power components. They draw everything up, but then we also want to apply that. So now we go back to what they learned before. They learned about gearing systems and tracks. We've added the programming and the PLCs with that, and now we've added pneumatic systems. How can we put that all together? So we put that together in a mechatronic assembly line. So like I said, we've scaffolded everything now. They have to do some systems thinking. They have to look at powertrains. They understand fluid power, programmable controls. And then the goal, the final project then is like, okay, now you have to make an assembly line. This assembly line has to have an object that goes down the line, has to stop for inspection. After it stops for inspection, then it has to continue down the line, has to have a hole drilled in the top, and then it has to be ejected off as a fully completed part off to the side. Now, how do you build that machine? They have to construct everything from scratch to get it to work. And this was an example. Now, again, this is just a model, but it's a way to show for students to show and actually demonstrate their understanding of all these pieces so they can apply it in the real world after they've done that on a model world. And we have a capability of running 5 to 6 of these at the classroom at one time, so they all can have that full hands-on experience. So the impact of this program has been very, very strong. Right now, they have 236 certifications in 31 states in the agricultural power technology and mechanical systems and agriculture courses. So I put some quotes on here. As you can see, Josh Day from Iowa and the impact it's had in his classroom. And he feels it's been really helpful for him. Grace Godfrey. So we have, this is a nationwide curriculum. She's out of Wyoming. Grace, actually, her students, after they did the tractor pull demonstration and everything in their school, their administrators really liked that, and now her students are presenting at they presented at a STEM conference in November in Wyoming. Her students were able to present there about what they learned in the course, how they applied those STEM concepts into agricultural mechanics and machines. Mark Meyer, who started out, he's a welding instructor in Kansas. He has students that have come out of there as certified welders. This has really built up his program. So now, besides just doing the welding portion, they're able to provide a lot of other ag mechanics areas. He's had students that have come back to him saying the value that these courses have had, especially in the electrical areas, understanding the digital multimeter and using that, have been very, very helpful for them as they become agricultural technicians. So one of the questions that I've received from a lot of people with EDA when I made this presentation in Louisville back in October was, how can we get involved? So we do have a handout I know I gave to Alex that I can provide for you guys as well about examples of getting involved with more descriptions here, but want us to connect directly with your secondary schools. Inform administrators and teachers about this curriculum, how it supports the workforce and ag industry, and if you have that direct connection with your secondary schools, get them on the CASE website. We have those trainings out there and available for them to go to. Promoting the teacher scholarships. We do not want funding to be an issue for teachers to attend to receive this type of curriculum. The Equipment Dealer Association has been very generous in providing scholarships for teachers to attend. So if there are teachers in your area that you would like to attend, talk to them about those scholarships, make sure that they get promoted. Another option that we're looking at now, which is new, is hosting a CASE Institute itself. Can Equip in Kansas this summer will be hosting a mechanical systems and agriculture training at their dealership, which I think is a great way to getting teachers directly connected to industry and when it comes to workforce development. This will be the first time that we're going to be doing this. It's really a partnership between CASE, Can Equip, which is going to be the host site. But when it came to the logistics, Kansas State University is going to work with Can Equip on the logistics of running the professional development while it's being held at Can Equip. Another thing to think about is donation of materials and equipment. One thing that we hear from teachers all the time, whether it's CASE curriculum or other curriculums, we can provide all the training for them, but they need to have the materials and equipment to use in the classroom to train their students. That has always been an issue throughout all school districts. So anything like that would be very helpful as well. And then on the end, Students complete these courses. They've proven that they can be problem solvers, that they can do troubleshooting, that they understand the core concepts that are related to all agricultural mechanics and equipment. And I know all of you are looking for those agricultural technicians that are out there, and there are sponsorship programs that sponsor students to get their education. Seek out those teachers that are using this type of curriculum. Talk to them to get in the class and get the classroom and talk to those students about how you're able to possibly sponsor them to go into a career to save on those extra costs for post-secondary education. Thank you again for all of your support. We have Ag Power and Tech courses this summer at Washington State and in Arkansas Tech. Mechanical systems and ag courses are going to be in Washington and Kansas this summer. And we're continually looking at new courses, and we're looking at the possibility now of implementing a capstone course for this with some direct hands-on applications with fully large electrical controls, hydraulics, and machine equipment to prepare them to go right into an agricultural technician program at a post-secondary institution, hopefully tying that to a credential so they receive some type of college credit from the post-secondary institution. What questions do you have?
Thanks, Carl. One question that came up is the CASE program more likely to succeed at a school that already has an ag program in place, or do they work everywhere?
That's a great question. In the past, our focus is with agricultural, within ag education. But having said that, we've had a lot of teachers that were not ag educators go through our trainings and be just as successful. And not as many in, I can't recall of any in the MSA and APT area, but I know in the food science, we've had some family consumer science teachers that have come through that have used the curriculum. And I know we've had business teachers and science teachers use the curriculum for animal and plant. But I do see this curriculum being directly tied to a lot of technical education teachers that may not have an ag background that would be able to very easily use it in their courses. So if you did not have an ag program in your local districts, your technical education programs would be the next step to talk to. And we've never been exclusive to just to ag educators. We start with ag ed, but we want to help all teachers be successful and prepare those students to move into the workforce.
Great, and just as a reminder, guys, if you do have a question, there's a little button on your screen that says Q&A. Just click that and you can type in a question. It remains anonymous. One more question is, what's the age group of students that are typically served by the teachers that come through the CASE Institute?
The age group of students vary from the curriculum here is designed for grades 10 and 11. So that would be from ages 14 through 17. Having said that, it varies based upon school districts. A lot of people use the Ag Power Tech course as a physical science applications in agriculture course for sophomores, and the mechanical systems in ag is a junior senior level course, normally grade so 11 or 12, and ages 16 to 18.
Great. Well, we don't have any other questions right now. Oh, just kidding.
Here we go. What class is being offered for teachers in Kansas this summer, and how much would it cost to send a teacher? The class is the Mechanical Systems and Agriculture course. The full cost for the training it's a $3,000 training for 2 weeks to attend. I know that there's scholarships out there that cover approximately half of that. So that gives you a little bit of information there, and I can send out the details on that on our web link about that information, and put you in contact with Richard Duggan, who is from CanEquip. He's the one that we're working with to host. Does this align with the requirements for national apprenticeships? That's a great question. If people that were at the Workforce Summit for EDA back in Louisville, there was a group from Pennsylvania that talked about the apprenticeship program that they're starting. I went through their apprenticeship program for level 1, 2, and 3, And I found that 70% of all the core concepts and ideas that were at the level 1 were in our Ag Power and Tech and Mechanical Systems course, and 60% from level 2 were there. Our thoughts is that if we add a capstone course, we recover the remaining percentage there so we can fully fit into an apprenticeship program. If you want to visit with local schools and educate them, is there someone to help us do that? Absolutely. If you have a local school district that you want to bring someone into, we do have, like I said, we have teachers across the country that are using this curriculum. We've had those teachers visit other school districts and talk about their direct experiences that they've had with this program. So if getting in contact with me, we can work some of those things out. If we don't have anyone in the area, I know that a lot of us with our case staff have traveled as well to talk to school districts.
So in the follow-up materials today, guys, we will send you the recording of this webinar, Carl's slides, the handout that we did about how to get involved, and then some contact information and additional information that Carl's mentioned for you to get started down the path of connecting with a local school. Does that cover everything, Carl?
Yeah, I think so. That sounds
Okay.
great. Thank you for your time.
Thank you. We appreciate it. There's no more question, guys. If you come up with questions, feel free to email me and I can pass them through, and we'll get them answered for you. Thanks so much, everybody, for your time today and for your patience earlier with the little technical difficulty we have. Enjoy the rest of your Wednesday.